We are now on a new topic, topic 9, which is probability. Most kids find this math the funner of the math, so it's a pretty fun topic. This is block 1 on page 271. And probability, what word sounds like probability? Probably. The word probably really came from probability, because if I said I'm probably going to the store, I can either go to the store or not go to the store. But is my chances higher of going or not going if I say I'm probably going to the store? The chances of going would be higher. And so I'm using probability when I speak that. Most people use probability all the time. Even animals use probability. They're conducting experiments. When you're training a dog to not chew on something as a puppy, he might get a spanking if he chews on it. Okay? He chews on it, he gets a spanking. Then when he's not chewing on it, he's not getting a spanking. Then the next day he chews on it, he gets a spanking. He's realizing the outcome of chewing on something results in my owner being mad. The outcome of me not chewing on something, my owner is not mad at me. So they are conducting an experiment as well. They don't know that they're doing it. You just naturally do it sometimes in life as a learning lesson. But probability has some vocabulary words that we need to look at. But first, let's kind of introduce probability. Think of Wheel of Fortune. You have the big wheel that you spin. Imagine one of the slots you could land on is win $1 million. The other sections are bankrupt sections. So, is it likely that someone would win? No. Is the game of skill, chance, or both? Chance. Okay? Well, obviously I'm stronger than Maddox, so if I go up there and fling the wheel and it spins a lot of times, is that spinning several times helping my chances any? No, it has no skill on it. He might spin it and it's super heavy and it goes around one time. Is that helping his chances any? No, it's based on chance. There's really not any skill to it.
Unless you really spin it.
Yeah, so go around once.
Right next to you.
Yeah.
Or after like skill, I thought you meant to run it up. Like when you said,
Hush, I can't hear.
like when you said skill and trick and break, I thought you meant like the part when you fill in the
Skill of filling them. Of Wheel of Fortune. I see what you're saying. The actual spinning of the wheel is chance, but the whole Wheel of Fortune game has some skill and chance in it. So I agree with you there. So it has both. So, what would my chances of winning $1 million be?
1 in a million.
1 in what? I called on one person. You need to remember I'm recording, so that's picking up. I need one person at a time.
It depends on how many sections there are. Let's say there's 12 and it's on one, and then it'd be 1 out of 20.
Okay. She says it depends on how many sections it could land on. If I just had 2 sections, half of it was win $1 million, half of it was bankrupt, that could be a pretty good odds, 50-50, right? But is that how their board is set up? I'm not exactly sure how many sections they have, but I can't answer that question until I know how many sections they have. this unit is really why Miss Adams is not a gambler. Because I know the math and the probability behind actually winning big. It is not very high. And so when I go, I'll go to the casinos and see people gambling, but I'm sitting back and I'm actually calculating, just because I'm a math nerd, I'm calculating the chance of them actually winning, and it's like 1 in billions in some games. So, but then you have all these, that's this section. Have you ever heard about card counters?
No.
There's a movie that is out that is, I think it's rated R, PG-13, so I can't show it. But there is a movie, I think it's on Netflix or Hulu, and it is called, what is it called? No.
They do that.
I'll think of the name in a second. But what the movie does is there is a professor from MIT, which is a big college, mainly focuses on math and science. He sneakily takes some of his strongest math students and teaches them how to count cards. What counting cards is you're keeping track. You know the cards you have in your hand. You know the cards that have been played. And you're able to calculate that quickly the probability of a next card being played to place a bet. Then you're also calculating and taking into account what other players have in their hands. So it's so much mental math that they're sitting there calculating this. But so this professor takes several of his math genius gurus, kind of teaches them the ropes of counting cards, takes them to Las Vegas, and starts winning some big money because they counted cards. It's what is that game? I played it with my brother. No. Is it Spades? Is Spades a game? Card game? I don't remember how it goes. I played that over the summer with my brother because he plays it with his friends all the time. And he didn't tell me that he played it with his friends all the time. And he wanted me to put money in it. And I was playing it, and as probably about the third round, I realized he had been counting the cards. I was like, "You're like card counting right now." He was like, "Yeah, you just got rigged." But he remembered every card that had been played to know what I was going to put down, and it really frustrated me. I was not very happy. So, all of that to say, that is probability. And that is basically our unit that we're going to be digging into. And it gets kind of fun. I like it because,
We like it.
yeah, true. All right, so first I want to define two definitions and pay attention to when I talk about trial. Trial, I'm skipping down to D, so I'm going to be skipping around. So, the definition experiment, where do you normally hear that in? Science. And what you're doing is you're conducting an experiment. Sometimes your outcome turns out good. Sometimes, can it turn out good?
No.
No, that's how some people found out that mixing a couple chemicals together causes a mass explosion. Okay? It didn't turn out good for them at the time, but then it kind of turned out good because then they knew those two chemicals can't be mixed. So they conducted an experiment. So, an experiment mathematically, which is the same as science scientifically, is the act of collecting data about probability scenarios. I want you to write my definitions like you see it, because this unit is kind of based on definitions. I also want you to write the example at the end. It says, for an example, rolling a number cube 12 times to calculate the probability of a sum of 6 is an experiment. What is a number cube?
Dice.
A dice. Some problems they call it a number cube, some problems they call it a dice. So please write all of that, right, King? Then you have trial, which skips down to D. A trial is like one action in an experiment. How many times did I roll the dice in this example experiment?
12 times.
12 times. But one time was a trial. The second time was a trial. The third time was a trial. So a trial is a single performance of an experiment, such as each time a coin is tossed or a cube is rolled. So if I flip a coin 5 times, each time I'm flipping it is a trial. I'm testing it. Yeah. Have you finished writing it? A couple people still writing. How many people still need the screen? Get it from your neighbor, okay? Okay. I gave each group a slip of paper. We're gonna conduct an experiment, actually, to help us with the other vocabulary words. And so what's gonna happen is, I have 2 through 12 of slots that I'm going to place some marbles in, like I'm betting. If I feel like a certain number is going to be pretty successful, then I'm going to have more marbles in that section. If I feel like the number would not be that successful, I might just put 1. There are 12 marbles to be placed. Then I'm actually going to roll the 2 dice and 12 times and see kind of how successful I was. So, why is there not a 1? It's impossible to get a 1 when you have 2 dice. The lowest number you could get is 2. The The highest number is 12. Well, if I had 3 dice, the lowest number would be 3. The highest number would be 18. Okay? So that is why we have the numbers that we do. So what I want you to do for like 3 minutes is with your group, you have a printout of kind of this chart. And I want you to determine where you want to place your marbles. Then I'm going to actually roll, and we're going to see which group had the best outcome. Okay? So, place 3 minutes. Alright, so I'm going to pick up a random group's paper and put this on my board just because I need some marbles placed. They had none on 2, none on 3. They had 3 on 4. They had 1 on 5, 1 on 6, 3 on 7. Move these over. And they had 1 on 8, none on 9, 1 on 10, and 2 on 11.
Hey, Miss Kelsey. You said
All right. This is just one group's opinion. So this is what I want you to do for every group. I'm going to test by rolling my number cubes and seeing the answer. If I have this groups on my board, so if they land on a 6, they're going to take that marble and add it to a scorecard. What you're going to do, if you had a marble on 6, you're going to put a check mark over that marble that it has been used. If 6 was used again, but you only had 1 6, you can't put a check mark. Or if you don't have a marble in that spot, you can't put a check mark. So that way you're calculating a score based on how many check marks you have. Makes sense? All right, so it is time to conduct our experiment and see how well each team calculated. So our first number rolled is a 10. So if you use a 10, put a check mark on the 10. If not, no check mark. Next number is 7. Put a check mark on 7. 11 is next. Put a check mark on 11 if you have it. 9 is next. If you have a marble on 9, you will check mark. 11 is next. So if you had 2 marbles on 11, you could have 2 check marks. Next is 7, another 7. Okay. 9, this is the second 9. 2. 12. That's 1 on 12. 8. Another 8. Oh yeah. And the last roll, 10. So Oscar's team ended up with 6 points. Okay? 8, 8, 7, 8, Peyton? 5, 5. All right. Okay. Now, hey, talking, quiet down. Now let me show you some math and why I would do things a certain way if I was playing this game. So, please tell me, using those two dice, what math problem can give me a product of a two? I mean, not a product, a sum of two. 1 plus 1. Anything else?
No. 2 times.
Is there a 0 on a number cube? Okay. That is the only math problem that could be created with dice to give me a sum of 2. So let's look at 3. What math problem?
2 plus 1.
2 plus 1. 1 plus 2. Anything else?
No.
So, looking at what information I have just right now, would I put more money on 3 being hit or 2?
3.
Would I put any money on 1 being hit?
No.
It's not possible. Okay, let's look at 4. What math here? 2 plus 2? 1 plus 3? 3 plus 1. Anything else?
No.
Okay, so based on what I know now, where would I put my money?
4.
On 4. Let's look at 5. What's the math problem?
3 plus 2. 2 plus 3. 4 plus 1. 1 plus 4.
Anything else?
No.
So based on what I know now, where am I putting my money?
Numero 5.
On 5 being hit. Because there is more ways that a 5 could be rolled. Let's look at 6. What do I have?
3 plus 3.
3 plus 3.
4 plus 2.
4 plus 2.
2 plus 4.
2 plus 4. 1 plus 5.
5 plus 1.
5 plus 1. Where am I putting my money now?
6.
On 6. Let's look at 7. How many? Or
3 plus 4.
3 plus
4.
4.
4 plus 3. 5 plus 2. 2 plus 5. 6 plus 1. 1 plus 6. That's it.
Where am I putting my money now?
7.
7. Okay, let's take a look at 8. Okay? Who thinks they're going to put their money on 8?
Not me.
Of course, only Joseph.
Alright. Well, if Joseph raised his hand, I would suggest not raising yours. Alright. What's the math for 8?
4. 7 plus 1.
There's a 7 side.
I wish.
6 plus 2.
That's where the problem starts coming into play. There's not a side that says 7. So, what else could give me an 8?
6 plus 2.
6 plus 2. Hold. Chill it. Okay. I have 6 plus 2. 2 plus 6.
5 plus 3.
5 plus 3.
3
3 plus 5. Okay. Based on this data, where are you putting your money?
7.
Still 7. I suggest Joseph never go gamble. Let's look at 9. 5 plus 4. 4 plus 5. 3 plus 6.
6 plus 3.
6 plus 3.
8.
There's not an 8 side. Any others?
No.
Based on what I know, where am I putting my money? 7. Okay. I'm gonna go all the way and look at 12. What is the only way I can get a 12?
2 6s.
6 plus 6. So where would I want to put most of my money? 7. Okay? But are you guaranteed to get a 7?
No.
The chances are greater, but you never know what's going to happen. Okay? So some of you had already kind of figured that out in your head when y'all were doing your own and knew which numbers to pick. Some of you were completely off. Some of you said evens were better. Well, it's kind of all spread out. Okay? All right, let's finish up with our definitions. Okay, remember I'm kind of skipping around. So the next definition I want to look at is outcome. So if I flipped a coin, I know there are 2 possible outcomes. What is one of the outcomes?
Heads.
It lands on heads, and the other outcome
Tails.
lands on tails. An outcome is what all the possible things that could happen. On a number cube, one number cube, I roll it, it could land on a
6.
6. That's one outcome. Roll it, it could be on
8.
4. That's the second outcome. So an outcome is the result of an experiment. For example, tossing a coin has 2 possible outcomes, heads and tails. Write that for your outcome. I suggest putting the examples. Then you have event. There is a event for some of us tonight. A basketball game is an event. Event is every outcome that could happen. It's a list of everything that could happen. So, basketball's playing Molo tonight. One outcome that could happen is
Molo winning.
Molo wins. Another outcome that could happen is
Molo loses.
Moss Bluff wins.
Oh.
Okay? The whole event is the basketball game, and one of those is going to happen, right?
Yes.
It's guaranteed. Okay? So the event is everything listed that could possibly happen. So any set of outcomes from the sample space of an experiment. For example, flipping a coin, you have an outcome of heads in one event and an outcome of tails in another event. You had yesterday in math an event that happened. You conducted an experiment of your math skills on topic 8. Is that based on chance or skills?
Skills.
Skills. Okay, if you studied for your math test and did your work, will your probability go up for your grade or down? Up. You did not study, your outcome could possibly be a low grade. Everything, or most things, can all be turned around to probability. Then, with your test yesterday, what part of the test would be the trial? Each question is a trial. So you're tested on one question. You either get it right or you're getting it wrong. Then you have another trial, number 2. Okay? The event is taking the test and listing all the possible outcomes, which is all the grades you could get, A, B, C, D, E, F, D, or A, B, C, D, F. Okay, and the last definition is like experimental probability. Experimental probability is actually finding the probability in the math behind it all. So I can say if I have a Wheel of Fortune spinner, I can figure out the probability of me landing on something, the math behind it all. So experimental probability, the math that we use to find that is in a fraction form. You can just write the fraction in part. And it is the ratio of the number of times an event occurred over the total number of trials in the experiment. So yesterday your experiment was the topic 8 test. How many questions were there? 14. So would that go in my numerator or denominator? Denominator, because it's the total number of trials. Then the number of trials, or number of times the event occurred, that would be how many questions you got correct. And that's how your grade has been calculated. Okay, and that concludes our first block. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and peace out.